Hello, my name is Christopher Moravec, and I'm going to talk to you today about building a spatial processing programming language. This is a follow-up talk to one I did a few years ago called Atelerix. So we'll call this one Return of Atelerix. So what is this all about? Well, I guess it's about building a programming language. That's really what Atelerix was meant to be. So we'll start with a history of Atelerix, and then we'll wrap up with, can I get Atelerix to run in WebAssembly? Because that was my goal, as we'll talk a little bit more about later. But first, a little bit about me. My company, Dymaptic, we're a small firm. We've got about 25 years of combined expertise doing GIS software development, but also other things. It's pretty great. I enjoy working there. We just released our first product called Infomaptic. It's a web-based reporting tool for ArcGIS. Lets you drag and drop fields and attributes and graphs and charts and things and create a report and then ultimately a PDF if you want one of your data. And it's important here because we used Atelerix to build it. And finally, a little about myself. I'm a software developer. I've got over 15 years of experience building things mostly on the Esri platform. You might have seen me at a previous Dev Summit standing on a stage talking about a sloth of bears. I also like building things with my 3D printer, and I currently live in Portland, Oregon with my two cats, Kumquat and Java, who hopefully will not interrupt this recording too much. Okay, so we're a consulting firm, and one of the ways that we learn to build software is by paying attention to what our clients' problems are. So there were two problems that Atelerix kind of grew out of. The first was that people wanted to make PDF reports. They just really wanted to be able to put all of their data on one page so they could view it online or on their phone or send it to their manager. So to solve that, we created Infomaptic, but it needed to be dynamic, so we needed some scripting behind it. The other problem that we often faced was getting data into a place that's visible. And ArcGIS solves that perfectly. You take data, you put it into a map, and people can view it. You share it, off you go. But sometimes you need to take that data and you need to process it and show some kind of derived output. And this is possible. You can use Python, write toolbox tools. There's lots of different ways to solve it. But I wanted something that was more like building a view in a database. So we created Atelerix. So what exactly is Atelerix? Well, clearly it's a four-toed hedgehog. And besides being very cute, it's also a programming language. So this is a screenshot of a very simple editor that I built. So you can just type in arbitrary Atelerix code and run it and get the output or get the console output. It's very simple and there's not documentation built into it, so it's a little hard to use if you don't know how Atelerix works. But it does function and you can write real code. So before we dive into trying to do Atelerix in WebAssembly, let's look at a brief history of where Atelerix was and where it is now. This started in 2019 with a Dev Summit presentation called Atelerix, a new language for analyzing spatial data. It was then a simple SQL-like language where you could take layers from different ArcGIS endpoints, combine them, and serve it back out as your own custom feature service. And the syntax looks something like this. You could create an object with a connection, and then you could run a SQL query and store it into a variable, and then you could do other things to those variables and further query them, filter them, and alter them. But I wanted something that was a bit more flexible. I wanted something that looked a little bit more like a functional language and less like SQL. And I wanted something that I could easily manipulate text and numbers as dates as well as spatial data. And so that's what led us to build a functional language, and we implemented it in TypeScript at first. It had a very simple syntax and a reasonable set of core functions for text, strings, numbers, dates, and geometry. So the same code that we saw before where we're looking at a SQL statement now looks like this. It takes a little bit more code to write it, but it's a little bit more comfortable and it lets us do more functional type things. But we ran into a problem. There was very slow interop between Infomaptic and Atelerix. We were running Atelerix in Node, and Infomaptic is a .NET app. So we had to move a lot of data back and forth between .NET and Node. And it ended up being pretty slow when you needed to do that several times. So we re-implemented this using the exact same syntax, but in a .NET standard library. So Atelerix is actually an interpreted language, which means that as it's executed, it reads that line and executes that line. So if it hasn't gotten there yet, it doesn't know if that line of code will actually work. It has its own custom type system that supports Booleans, dates, text, numbers, lists, dictionary, and functions. And in Atelerix, a function is just another data type. So let's take an example here. So this is a rather verbose way to calculate the Fibonacci sequence. And basically this code creates a function called fib and returns, takes in a single number and returns that number, that ith item in the Fibonacci sequence. So down there at the bottom, you can see we take a map, we map a list of 0 to 5 over the Fibonacci sequence, and we join it with a comma, and we get 1, 1, 2, 3, 5, 8 back. You can write this in Atelerix another way using a ternary expression. It's much simpler, less verbose, but you get the same result, 1, 1, 2, 3, 5, 8. So that's all pretty great. It's a pretty fully functional language, and we've been able to use it quite successfully inside Infomaptic to automate things and to do things dynamically. But while this was all happening and I was working on this, WebAssembly showed up and people started really making progress on it. So what is WebAssembly really? Technically, it's a binary instruction format for a stack-based virtual machine. Well, that's kind of a mouthful, but basically it's a small virtual machine that runs inside the browser that you can send instructions to. And it's stack-based, so that means you can say something like push a number onto the stack, push another number onto the stack. Now add those two numbers. Now pop that answer off the stack, right? It works kind of like that. And it turns out that .NET is also a stack-based virtual machine. Lots of languages and other platforms are as well. So we've got this kind of WebAssembly thing, which is not JavaScript, going on is parallel to me working on Atelerix. And we're now seeing WebAssembly start to become pretty mature, right? So we're seeing there's lots of compilers and tools now for you to compile C into WebAssembly. And folks like LibreOffice are working on compiling their desktop application or converting their desktop application to make it compatible with WebAssembly. And I think that probably WebAssembly is going to make it a lot easier for folks to get desktop applications in the web, and probably will end up making them a lot more efficient than they would be if they had been rewritten from scratch in JavaScript. So what's .NET doing in WebAssembly? Well, .NET has this thing called Blazor, which if you've used ASP.NET, then there's these things called Razor pages, which are dynamically generated on the server and served out as HTML. And .NET takes the same approach, but implements it so that it can run client-side in .NET. So that's pretty cool. That actually means that there's .NET code running inside the browser. So this idea of running a Atelerix in WebAssembly is starting to look a little bit more realistic. So what if I could run Atelerix in the browser and on the server? Could I extend Atelerix to build UI components where certain things are run on the server and certain things are run on the client? That sounds pretty cool. And like we just talked about with Blazor, you can run .NET in WebAssembly. So the question is, how do I get a DLL out of Atelerix code? Because that's ultimately what I need in order to run WebAssembly in order to run .NET code in WebAssembly. I need a DLL. So let's talk about how DLLs get generated. We take our source code, C#, VB.NET, or F#, and we run it through a compiler, and that creates an intermediate language or common intermediate language, which is really what talks to that stack machine. Then the .NET framework or the .NET runtime takes that intermediate language and just-in-time compiles it and runs it on the platform of your choice. Okay, so there's lots of steps in here, and now with .NET 5, we have lots of different platforms. Linux, Mac, Windows, and now through Mono we can compile for WebAssembly also. So it turns out that all of these use the same intermediate language, which means I can build a DLL and I can share it across all these platforms. But I'm still stuck with how do I generate that DLL? So there were three different ways that I came up with that I did research for here. The first was Ling Expressions. The second was ILGenerator. And the third is Roslyn, which is the .NET compiler. Okay, so let's talk about Ling Expressions. This is all in the namespace system.link.expressions, and it lets you basically create a compiled function. So I can string together any built-in .NET component and build a Ling expression, and it's very much like using Ling within C# or .NET. But it gives me a compiled function that I can work with. And it's almost as fast as if I had written that code in C# myself. So I've used this before to do domain-specific languages, and it works fairly well. But I've never needed to compile it into a DLL. So it turns out that .NET Framework can compile to a DLL, but .NET 5 and .NET Core can't do that yet. On top of that, Ling expressions are considered mature, and they might not get updates in the future. So this didn't seem like a great place to be. And plus, Ling expressions were a little bit limited because I wanted to be able to build in things like async tasks into Atelerix in the future. So this took me to ILGenerator. And this is all through the namespace system.reflection.emit. And it allows me to directly generate that intermediate language code. This is really low level stuff. This is like writing WebAssembly by hand. If you had to, and you can do this, there's a couple of websites where you can go and write WebAssembly and it'll compile and run it for you, and you can, or at least the text version of WebAssembly. It's very low level. You're manipulating that stack machine directly, but it can generate a .NET DLL even in .NET 5. So this is closer to what I wanted, but it was going to take a lot of work to convert Atelerix directly into this low-level stack machine manipulation. You still have access to the whole .NET standard library, so I can still do things like call functions on strings, but I was going to have to convert all of that into this IL code. On top of that, the IL generator is also considered mature and might not get updates in the future. And this is kind of a shame because I think this is actually pretty powerful. Along with expressions, you can really optimize something for performance by generating that IL code yourself to make it behave in a very specific way, which is very powerful. So I hope this doesn't really go away. So that leads me to Roslyn. And Roslyn is actually the code name for the C# or .NET compiler. And it lives in the namespace Microsoft.codeanalysis. And what it does, or what it was originally meant to do, is it lets you take a C# code and gives you a syntax tree back. And you can then traverse that syntax tree like an XML tree. And you can look for things in it. So it helps with optimizing code or refactoring code, things like that. But they also let you build that syntax tree programmatically through Roslyn. So what this means is I could build a transpiler, something that converted Atelerix into C#. And of course, through Roslyn, I can generate a DLL in .NET 5 because that's what it's all about. It's about building, generating DLLs. And this is pretty much the state of the art for compiling C#. So it's not going to go away anytime soon. All right, so let's take a look at what that looks like for us. So we start with some Atelerix code. And here I have a very simple Fibonacci computer, and it will compute the ith index of the Fibonacci sequence for us. So you put in 5, you get 8 back. So there's some Atelerix code. And this code is a little bit different than what you looked at before because I've been enhancing the language as part of this exercise. I took out the var statement because it seemed kind of redundant because anytime everything's a var. I also added type hints because inside the Roslyn compiler, or inside C#, I should say, I wanted to be able to specify C# types. So I added type hints into Atelerix as well, and those are optional, but I've included them here just to make it super clear what's happening. So we take that Atelerix and we transpile it into C#. And so here we see that same function, but written in C#. And this is all done through syntax tree manipulation. So I'm not doing any string wrangling here. So what's really cool is basically I can map things in Atelerix into C sharp. So that ternary expression in Atelerix can map into a ternary expression in C sharp. Or, which is what really happens, is Atelerix maps a ternary expression to a function called IIF, which is pretty common in lots of languages. And IIF takes in the same arguments as a ternary expression and returns a result. And then we map IIF as a function into a C sharp ternary. So that means that inside of Atelerix, you can use the ternary syntax, which is just sugar on top of the IIF function call. So Atelerix is kind of processing that and generating the best C sharp version, depending, even though there's more than one way to do it inside of Atelerix. So once we have this C sharp, we can generate our Fibonacci DLL, which contains this function. And then we can go, I'll eat cake. Almost. Part of the cake is a lie. It's not completely a lie, but there are some things that don't work quite the way I expected. Well, one in particular. So let's look at some code now. Over here on the left, I have my Fibonacci.at file, which is an Atelerix file that contains my Fibonacci functions. And this has got a couple of functions in it for demo purposes. This first one here is what we were just looking at. It's a simple Fibonacci index computer. Then I've got this one called fibtext. Well, it turns out that not all data types can be converted from .NET into JavaScript, and decimal is one of them. Something I maybe haven't mentioned is that Atelerix doesn't use integers and floats. It only has one data type, number. And under the hood, it's using .NET system.decimal. And system.decimal is powerful because it does math the way humans do. So you don't end up with weird floating point things, but it's much larger to store and much more expensive to do that math. So there's a trade-off. But for the types of things that Atelerix does, it made more sense, I think, to make that trade-off and have math be a little bit more predictable and a little bit more understandable for folks. So since a decimal can't be decoded into JavaScript, we need to convert it into text. So fibtext wraps that fib method, but converts everything to text. So it takes in one argument as a string, it converts it to a number, and we pass that into the fib function, and then we reconvert the result of that back to text and return it. So we're not doing anything complicated. We're just very simply converting the number passed in, or the text passed into a number, getting the Fibonacci value back and turning it back into text. And because we are at the Esri Developer Summit, I need to do something spatial. So I also have a little buffer function here, which uses Atelerix's built-in geometry engine to take a point and then buffer it and return that as text. And because I don't have anything fancy going on here, we're not going to do anything like try to convert it into an ArcGIS JavaScript API object. We're just going to convert it to well-known text and print it on the screen. So nothing really overly complex. So one feature of the Atelerix compiler is that it can generate the C# code for that Atelerix. So over here, we see that basically every function that I've defined in this Atelerix file has become a static function over here in C#. Okay, so same process that we talked about before, but you can see all three of these are here. And you can also see that we use some built-in functions inside the Atelerix runtime to do conversions between text and numbers. And those are actually also written in Atelerix and compiled to C# through the compiler. So it's kind of cool that Atelerix's own runtime is built in Atelerix through its own compiler. So that's pretty cool. All right, so we've got all of that. Now what we need to do is compile this into a DLL. Before we do that, if we look over here in our folder, our Fibonacci test folder, we see there is no DLL here yet. So now what I'm going to do is I'm going to run the compiler here, and it's actually going to stop us at a breakpoint. And we'll get to look at this quickly to see just exactly what's happening here. Okay, so here we are stopped at that breakpoint. And you can see we're basically loading up a C# compiler here we're adding in our syntax tree, which is that generated C# code just stored as a stream, and then we're going to compile it. One thing I want to point out here is that we're adding references. Instead of adding references to the .NET runtime, we're adding those references into WebAssembly or into the mono version, the mono .NET library that is built in WebAssembly. So we're adding those references here. And now we're going to omit that compiler. We're going to use the compiler to omit that DLL. So I'm going to step over this here just so that we can inspect this. And we'll see that our compile result, our success is true. We have no diagnostic output, so our DLL should be generated. So now when we go look at our folder, our files, we see right here, we have a DLL that's been generated. All right, so that's pretty cool, but now we have to get it onto the web. So this is where we're actually going to use Mono. We use these references up here, but now we're going to use the Mono packager or the Mono WebAssembly packager. And what this does is it says, take this DLL and package it. And if there's any references that aren't built into the Mono WebAssembly, then go get them from this folder. So the one that we need is the Atelerix runtime, which is built in .NET Standard, so it can just come right over. Okay, so I'm going to run that, and it's going to package all of those up and move files around so that they're all there. And now in our publish directory here, we have some JavaScript, we have a WebAssembly file, our HTML file, some more JavaScript, and inside the manage directory, we have all of these DLLs. All right, so now we need to run it. So we'll use .NET Serve to just run this locally. And as soon as that starts up, we'll open that in a browser here. There we go. Okay, and here is our code running in the browser. So we can click on Fibonacci, and it gives us 8. Okay, so if we go back to our source code quickly, we look at our index.html. When we click on that, we call execute 5, which execute is bound through Mono to this static method called fibtext, which was generated from our Atelerix code. So when we passed in 5, we should get the 5th item in the Fibonacci sequence, which is 8. So now in our other function, we're going to buffer a point. And this point is in Palm Springs, where hopefully we'll all get to see each other next year. And let's see what we get. And there's our well-known text for that buffered point. All right, so that's pretty cool. We've taken our Atelerix code, compiled it to C#, packaged it into a DLL, and packaged it all up with WebAssembly and are running it in the browser. That's pretty great. So in summary, it works. And it works pretty great. It's very fast, and I was able to get my Atelerix running on the web, which is what I wanted. System.decimal doesn't have a JavaScript representation, so I'm going to have to do some figuring if I want this to work in the long run, maybe even putting in a PR to get system.decimal to work inside the Mono WebAssembly build. So where do we go from here? The first place, I think, is back to its roots. So Atelerix started out as a spatial processing language, transforming ArcGIS data. And I think it needs to head back towards that and really focus on taking data from multiple sources, mashing it together, and producing a new feature service. Someone suggested to me not that long ago that maybe the syntax should change and this should become an open source version of Arcade. I thought that was kind of an interesting thought. I haven't decided whether or not to open source Atelerix, but I think that if I move towards this Atelerix to C# compiler, I definitely will. And the third thing that I've been thinking a lot about recently is, do we even need Atelerix? Is it serving a purpose? Is it solving a problem? And I think the answer is yes, but there might be other ways to solve it, like just using C# as the scripting language or Python. I worked pretty hard to make sure Atelerix was sandboxed really well. And even in the C# version, you can't reach outside the sandbox. You can't just call any old C# library to talk to files on disk and stuff like that. So it's pretty well protected. But there's other ways to solve that problem as well. So I'll be thinking a lot about that and other things going forwards here. And that's the return of Atelerix. If you've got questions or you want to chat, please feel free to email me. My email's on the screen here, and it's also in the slides. Thanks for watching, and I hope that you found this pretty interesting.